Hi guys, welcome to our channel DevNode. So today we are solving LeetCode question number 746 and it is easy. So this is the first video of our play DP and recursion playlist. So let's see what is question. The question is minimum cost to climb trees. So let's read the question. So what question says, you are given an array cost where cost of I is the cost of ith step on the staircase. Okay. Once you pay the cost, then you can climb either one or two steps. So first you pay the cost, then you can climb one or two steps. Like suppose this is our array, so this is ith. Now what is the cost here? Cost is 10. Once you pay the cost, then you can move either one step or either two steps. You have two options, and you can either start from the step with index 0. So we can either start from 10 or either with index 1. So what is 115? So either we will start with index 0 or 1. We can start from any of them. Return the minimum cost to reach the top of the floor. So we need to figure out the minimum cost to reach the top of the floor. And remember, the top of the floor means at the end, after the end of the index. Generally we consider this as the top of floor, but in this case this is not. This is the top of. Now let's here for 10, let's understand this. Here we have options, like at each index we have two options, either we take one step or either we take two steps. So whenever you see in question that at some stage we have multiple options, we can move in any direction. In these type of question, think of recursion, because most of the time these questions will get solved by recursion, or at least their brute force approach should be completed with the help of recursion. So here we know we at each index we have two options. So let's dry run this question. Okay, so let's see the tree diagram. So we have two options, either we start from index 0 or start from index 1. So first we start from index 0. Start from index 0. So this is array. So at each stage we have two options, either we take one step or two steps. So let's see, we take one step, we reach here, but what is the cost to reach here? The cost we took is 10. Now we took one step, we reach this index at 15. Now again we have two options, either we take one step or two steps. We take again one step. Now we reach at index value 20 here, and what is the cost? Cost took 15. Now we reach this index. Now again we have two options, either we take one step, two steps. Now again we take one step. What is the cost? The cost it took is 20. Now we reach end of the index, we reach out of the index, or we can say we reach the top floor. So what we will return? We will return 0 from here. Now we will return 0. What we will return here? 0 plus what is the cost that it took? So this, at this function call, we will get 20 from the left side. Now go to the right. When we took the two steps, here we get the same, we reached out of index, we return 0, and the cost it required to reach here is 20. So we will get 20 from left or right, both we get 20. And what we will took, we need minimum, so we'll take minimum of both. So we took 20 because this is minimum. Now from this path we get 20. Now let's go to the second path where we took two steps. Now here we reach the end of the index. Now again it will return 0. What is the cost it took to reach here? Is 15. So 15 plus 0. So from here we will get 15. From left side we get 20. From right side we get 15. So what is the minimum? 15. So we will return 15. We will return 15. Now 15 plus what this function call will get? 15 plus the cost it took, which is 10. So from left side here we will get 15 plus 10, we will get 25. So we will get 25 from the left side for 10. Now let's check at the right side. Right side we take 2 steps, we reach here. Again 2 options. First we take 1 step, we will get here. The cost it goes to here as 20, so we will get 20 from here. Here again we reach, it also returns 0 plus 20, cost it will took 20, so from both the side we will get 20. And from here what the cost will took, the cost it will took is 10, so 20 plus 10 30. So from here we will get the 30. The minimum we got from left or right is 30 or 25. The minimum is 25. So this is our answer as of now. So what we got, so if we start from index 0, we will get 25 as our answer. But remember, we also start from index 1. So let's start from index 1. Here we will start from index 1. So start from index 1. Now 1, we have 2 options. First we go to the left, take 1 step, we will reach here. Again we take 1 step, we will reach here. The cost it will took to reach here, this is 15, it took 15. Here we took 20. Now here we go out of bound, so we'll return 0. 0 plus 20, from here we will receive 20 left side. From right side same, it will return 0. The cost it will stay 20, so it return 20. Minimum of 20, we can get anything. So what we will return from left side, we will return from left side 20. From right side we take 2 steps, we will reach end of the day, so we return 0. How much cost it took? 15. So what is, from left side we will get 20, from right side we will get 15. From left side we will get 20, from right side we will get 15, so we will at the end we will return 15. So from index 0, if we start from index 0, we will get 25 as our answer. And if we start from index 1, we will get 15. So what is our answer? We need minimum, so minimum of 15 or 20, that is 15. So this is our answer. Now let's see how we write code for this. So as we discussed, at each level we have 2 options, option 1, option 2. First option we took 1 step, second option we will took another step. Plus we also need to add what is the cost it required to reach this index, which is cost of I index. So we will add cost of IDX to the both. Now what we will return? We will return minimum of both. So minimum of option 1 and option 2. And what is base condition? Our base condition is if our index is greater than or equal to n. N is nums.size, nums array.size. What we will return? We will return 0. So this is our code. Now let's discuss time complexity. So if we see our tree diagram, at each level we have 2 options, again 2 options, again 2 options. So at each level we get 2 options, 2 options, 2 options, 2 options. So what is our time? Our time complexity will be exponential. It will be how many options we have at each level, 2, and how many number of nodes, n. So our time complexity will be 2 to the power n. This is our time complexity. And what is our space complexity? Our space complexity, how many nodes we have? N. So recursion will take O of n as the time complexity, the space complexity. So that's it, guys. Let's code this solution. Now let's discuss about the let's discuss can we reduce its time complexity? So from 2 की power n, can we reduce this to of n or n square? See, if you see the tree diagram carefully, observe, here we are making call for 20. Again here we are making call for 20. Here we make call for 20, here we also make call for 20. So we are repeating the calls for 20. So there are repeating function calls. What if we save the states? What if we save the states of the function call? So we can use memorization. So we will create a DP array, our DP array of size n and initialize with -1. If at any point, if our DP of index is not equal to -1, that means we put some values in that. So we will directly return that value, because we do not need to further execute the tree, because it will reduce our this. From this function call we will call this tree, here we will again execute this tree. So these our workflow will get reduced. So we'll directly return, because we already calculate here the value, what is the value we got at if we call this function. Then here we do not need to again do the same calculations. We will exactly store the calculation for this, and if it is there we will directly return the value from here without calling these functions. So in our code we will just write if dp of index is not equal to -1, and where we assign dp of index here. Before returning, we will write dp of idx equal to minimum. So here first, when first will dp of 20, we will assign some value, and when the same function gets called, repetitive call happens, it will check here, and if it goes get the value, it will return the value directly from here. So here it will reduce our time complexity. How much? See how many different function call we have. So in our question we have three things: 1, 15 or 20. How many different function call? 1 for 10, 1 for 15, 1 for 20. So maximum time complexity will be of n. So we reduce, because these are unique function calls. Unique function calls, because we are not recalculate for the duplicates. So our time complexity reduced from 2 की power n to O of n, and the space complexity, apart from the regular stack space which is O of n, here we use dp array which also take O of n, the unique values. So here our space complexity will get increased, but our time complexity will reduce from 2 की power n to O of n, linear time complexity. So this is time dp. We can change the code of the recursion by adding few lines into the dynamic programming code. So that's it guys. Now let's code this both the solutions. So let's start the code. So first we will create our function. We'll call our function, and starting first from index 0, and we also have another option to start from index 1. So I'll start with index 1, and suppose this is our option 1 and it is our option 2, then we will return minimum of option 1 and option 2. Now let's write this function. So int solve vector of int cost or int index, starting index. So how many options? So we have two options. One where we took one step, plus what is the cost present at index. Again second option, we will take again the same we will add the cost, and here instead of one step we will take two steps. And what we will return minimum of option 1 and option 2. What is our base condition? When this index reach out of bound, so we will return index greater than or equal to cost dot size. We will return 0. See, the code is as simple as that. Now let's execute this. Yeah, we passed our example test cases. Now let's submit. Okay, so we got TLE, time limit exceed. We need to optimize this code further. So let's how we optimize it. You can use dynamic DP array, where we'll store the state of a function call. So we will see what is the size of array, cost dot size, comma -1. Initial value is -1. We'll pass this array as it is. We'll pass this array. Then we will vector of int dp. Here we will check if dp of idx is not equal to -1, because initially we initialize is -1. If it is not equal to -1, that means we add some value in here, so we will return that value as it is. And where we are adding the value here, before returning we will store the output which we got for this index, and in this two functions call we will pass the dp array. So now let's run it. Yeah, it passed our example test cases. Now let's submit. Yeah, see, our code has been accepted. See how we convert this recursion code into a dynamic program by just adding these two lines, one here and one here. And this is all about dynamic program. It's memorize the already solved equations. So we already solved for this index, then we store its value, and before calling the functions we will check, do we already solve this? If yes, then we will return the answer directly. What is its time complexity? Time complexity for this optimized solution is O of n, because we iterate only n unique indexes, and is number of cost size of an array. So thank you guys. If you like the tutorial, please like and subscribe.